Alright, here's a classic one. Given an array of numbers, find the k most frequent elements. So if you've got 1, 1, 1, 2, 2, 3, and k is 2, you want 1 and 2, because those appear the most. The core insight? Count everything up, then grab the top k. And Python gives us some beautiful tools to do this in basically 2 lines. We're pulling in 2 heavy hitters from Python's standard library. Heap gives us heap-based algorithms, super efficient for finding top k anything. And counter from collections? That's our frequency counting machine. These 2 together make this problem almost embarrassingly simple. Here's where we build our frequency map. Counter takes the entire nums array and gives us back a dictionary-like object where keys are the numbers and values are how many times they appeared. So, 1, 1, 1, 2, 2, 3 becomes 1, 3, 2, 2, 3, 1. One line, all the counting done. No manual loops, no if statements, counter handles it all. And this is the key insight, heap.largest does exactly what it sounds like. It finds the n largest items from any iterable. We're asking it, hey, from all the keys in our counter, give me the k biggest ones. But biggest by what? That's where the next piece comes in. Watch what happens with that key parameter, key equals count.get. This tells largest how to compare elements. Instead of comparing the numbers themselves, it looks up each number's frequency in our counter. So it's ranking elements by how often they appear, not by their actual value. It's like sorting students not by name, but by their test scores. Time complexity here is n log k. We scan all n elements to count them, then the heap operation processes k elements at a time. Space is n for storing the counts. The beautiful takeaway? Python's standard library is ridiculously powerful. 2 imports, 2 lines of logic, problem solved. Know your tools and hard problems become easy problems.